All right. Algebra 1, folks, thank you for hopping in with me today. Here we are going to be looking at Lesson 30. Lesson 30 focuses on sequences. And our goal today, by the time we get out of Lesson 30, is to be able to write explicit and recursive formulas for sequences. I'll give you a second to jot that down. Our goal, again, we want to be able to write explicit and recursive formulas for sequences. Sequences themselves shouldn't be something that you're unfamiliar with. You should have some experience in at least being exposed to sequences, and I'm sure you have. You'll notice these things look familiar. They're probably test questions you've seen before, but we're going to put like an algebra spin on it today with these two kind of key terms here being explicit and recursive formulas. Is kind of going to be our main focus today. All right, so let's hop in and just look at this preview here. On our preview, let's see if I can get this off here. Preview says find the missing terms in each sequence. So here we have 5, 10, 15, 5, 15, 25, 35, blank, 45, 55, blank, 75. Well, I already noticed I actually made a mistake, so let's act like this one is not there. 5, 15, 25, 35, 45, 55, blank, 75. We should be able to fill these in based on skills we already have, right? We can tell this is counting by, this is growing by 10. And if that's the case here, 55 plus 10 would be 65, right? Because it's a plus 10 pattern. Next, we see 6, 3, 0, negative 3, blank, blank, negative 12, negative 15. I can tell here and here and here and here. I can tell it's decreasing. It's getting smaller, right? We get from positives to negatives. By how much? We're subtracting 3 every time. So if that pattern keeps up, negative 3 minus 3 would be negative 6. Negative 6 minus 3 would be negative 9. And so on and so forth into the negative 12, negative 15. This next one here, we see 3, 8, 15, 24, blank, 48, 63, blank, 99. Okay, so what we're looking for some kind of a pattern here, right? So from 3 to 8 is plus 5. Is it plus 5 again? 8 plus 5 is 13? No. So this one, 8 plus what number is 15? That would be plus 7. This one here looks like it would be 15 plus 9 would be 24. So this one's looking a little bit different than the previous two, right? We don't have a constant increase or a constant decrease both times. But I do see a pattern, right? These are 2 apart. You're looking for like a difference in the differences. This would be plus 2. This would be plus 2, right? So this would be 5, 7, 9. This one should be plus 11 if the pattern keeps up. And 24 plus 11 would be 35. Does that keep up? This should be plus 13, which it is. This should be plus 15, which it is. That means this should be plus 17, which would be 80, would be that one, right? It's increasing every time, and the difference is increasing by 2. Plus 5, plus 7, plus 9, plus 11, plus 13. Different kind of pattern. Let's go ahead and rock and roll with that. So here we're going to get a definition of sequences. A sequence, really at a basic level, it's just an ordered list of elements or terms. An ordered list of elements or terms. Okay, you've seen them before. Sometimes instead of getting like numerical sequences, you'll get like a visual, like a picture, which we'll see here in a little bit. Okay. So here we get a little bit more in depth instead of just maybe some of the basic ones you've seen. We get some different looking. These are sequences below. Here we're looking at A and B, and we're trying to see if we can fill in these 2 blanks. Here we see A1, A2, A3, A4, dot, dot, dot. That's kind of saying, hey, assuming this keeps up, this is A100. So what would go right before A100 and what would go right after A100? So, I mean, obviously we can tell the variable A is staying the same. And then we just have, it's increasing by 1 every time, plus 1, right? So I'm thinking, okay, well, if that continues, what's right before 100? Well, that would just be A99. Oh, what's right after 100? This should be A101. And that's called subscript notation, those little numbers down there below, okay? So again, just kind of a different, hey, it's still a sequence. It looks a little bit different than just numerical values. Just still recognizing a pattern, right? If I know this is A100 and I see over here it's plus 1, then I know that that's got to be A99 and that's got to be A101 if that pattern holds true, which it looks like it does. All right, so here we get this. This is kind of to help us out here once we get to the next page. Same pattern, A1, A2, A3, A4, dot, dot, dot. Then this says AN, which is something we're going to see today. That's just saying, hey, the nth term. The nth term is like in reference to just, it's just a variable holding the place of a soon-to-be number. So eventually, hey, AN, the nth term could turn into, I could turn around and say, hey, I want to know the 77th term of this sequence, or the 85th, or the 16th, right? If this is A sub n, well, this one I know is, this one here is one before that. So that would, we could just call that A n minus 1. If I just do n minus 1, I should get this. And the opposite on the other side, well, if I just do A n plus 1, meaning this, I'm gonna erase this little here. Okay, if I talked about calling these A, or n being a number, say that I then call this one, this is A to the A 57. Well, if this is 57, then I just need to add 1 to 57, and that would be 58 over here, A sub 58. And that means I would need to subtract 1 from 57 over here, so that would make this A n sub 56. Whoops, no n. A sub 56. Just kind of a more of a generic variable. Look at that there. Okay, so we're going to focus today on really not just sequences, but arithmetic sequences, okay? Arithmetic sequences is a sequence of numbers with consecutive differences. Okay, meaning, all right, we're just looking for ones that have the same consecutive differences. Like we're going to take a look at these ones up above again, right? Let's go back and let me change color here. All right, I'm going to look at 1, 2, and 3, and I need consecutive differences. Consecutive means in a row. Differences means, or I'm looking for, a sequence of numbers with, let's call this, I'm going to go ahead and add a word down here, with the same consecutive difference. I think that might be hammering it a little bit, but I'd rather speak on it too much than not enough. We're looking for the same, right? So like we saw in this first one, plus 10, plus 10, plus 10, plus 10, right? That is a consecutive difference. This one, minus 3, minus 3, minus 3, minus 3, minus 3. Okay, this one was a sequence, okay, but it's a different kind of sequence. It is not an arithmetic sequence, right? Plus 5, plus 7, plus 9, plus 11, plus 13. There was a pattern, okay, that we recognize, but it was not an arithmetic pattern. It was not an arithmetic sequence, okay? So let's go ahead and put that down here. Looking at the first 3 problems we did in the preview above, were those 3 arithmetic sequences or not? One was plus 10. Yes, it was plus 10 every time. This one here was yes, it was minus 3. And then this last one here is no, because it was not a constant difference. Okay, looking down here, just why sequences, again, a very popular test item here. This is actually taken off of a state test that previous students took in order to graduate, okay? So you'll see some patterns like this. It'll like a very popular question would be like, how many blocks are in image 17, right? And our goal today is for you not to have to draw the 4th one of this, the 5th one of this, then the 6th one of this, all the way to the 17th. Right, that will take you a lot of time. It will take you a lot of effort, and it's kind of unneeded. Right, we're looking for shortcuts using mathematics, in kind of in like a formula sense. Right, we talked about that recursive and explicit formula. How can we use that in order to answer questions like this? So let's let that hop down into page 2. Okay, page 2 is recursive. Recursive, I want you to think of like a now, then next. All right, meaning this, and I'm going to put quotes around that, and I'd like for you to do that too. Something like if I say, well, now it's 7, and the next is 10, or now it's 18, then next is 20. You're just saying, hey, if I know this term, I can tell you what's next, right? Like a very basic example we're going to see here in a second. Recursive helps a lot more if you have a question that's not far away. Right, meaning like this one right here, if I said the 17th picture, you'd be like, I don't know if I want to draw 17 of those, right? Or I don't know if I want to do this recursive formula 17 times, right? This is maybe better if I say like, what's the 8th number? And you know the first 5, and you only have to go a few more. is when this would maybe come more in handy. Okay, so here's the sequence we're going to look at. It's 7, 10, 13, 16, and it goes on. Okay, so here's what we know. We need to recognize, hey, this is growing, right? It's getting bigger. Let's make sure it's an arithmetic sequence. This looks like 7 plus 3 would be 10, plus 3, plus 3, and so on and so forth. So, okay, we see that there's a constant difference. That difference is plus 3. Okay, and then we have this table set up, and this is what I want us to focus on today. Okay, this formula here. This is our recursive formula. It's read as the nth term equals the nth term minus 1 plus d. Okay, and I want to explain what these things are. An is just stands for the nth term. Okay, a sub n minus 1 is just the term before the nth term. Okay, or before, let's say this, before the nth term. And then d stands for the difference, which we just found out, right over here. The difference is plus 3 in this pattern. All right, so let's fill out this table. Here's kind of where this table comes from. This is saying, hey, term number, our first term is 7. That's a key number, okay? So we need to know that, our first term is 7. And then we see, okay, well, in order to figure out what the next term would be, we would need to take our second term is just our first term plus the difference. Well, that's the same thing as saying, well, our first term is 7. The difference is 3. Well, what's 7 plus 3? It's 10, right? So we would say, hey, this term number is 10. Okay, or the term is 10, This is now saying, hey, well, the third term. Well, the third term is just going to be whatever the second term was plus the difference. Well, that's the same thing as saying, well, what was the second term? We see that here. That's 10 plus 3 because the difference is 3. That 3 stays the same. Well, what's 10 plus 3? 13. Okay, so on and so forth. Here we see the fourth term. Well, that would just be, well, that's the third term plus the difference. What was our third term? Well, our third term was 13. What's the difference? It's still 3, so that turns us into 16, so on and so forth. And we need like a generic, right? So if I wanted to, for this sequence right here, this guy, if I wanted to make a recursive formula for this problem, it would look like this, okay? Our nth term is just going to be our previous term plus the difference of 3. Okay, meaning I can figure out whatever this is by taking whatever the term before it was and just adding 3 to it. So if I would ask you to say, I don't know, if I say, what's the fifth term? Oh, the fifth term would just be, okay, well, that would be the fifth term minus 1 plus 3. Meaning, well, 5 minus 1 is 4, so it's saying, hey, whatever the fourth term is plus 3, that's going to be our answer for what term number it is in the sequence. Okay, let's use this a couple times, right? Sometimes repetition really helps. Excuse me. Write the explicit expression for the arithmetic sequence from this preview. Okay, so here we're looking at, it says 5, 15, 25, 35, 45, 55. Okay, I should be able to tell right off the bat, this is growing. It's growing by 10. Does it do it constantly? Yes, so we do have an arithmetic sequence. D, what's the difference? So our difference is 10, a positive 10. That's key. Okay, and then what's our explicit equation here? Okay. Okay. This should actually say recursive. That's why I had that pause there. I put the wrong word in that place. What's our recursive equation? So making an equation like we just made to figure out whatever, any term if I'm saying, hey, this is the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth. If you get asked, hey, what's the 13th term in this? We're just going to need some sort of general formula, which is whatever term we're being asked about is the term before it plus 10. Okay, meaning, again, if I say, hey, what's the 15th term? I want to know what the 15th term is. Well, the 15th term is just going to be the term before it plus 10, because 15 minus 1 is 14. 14th term plus 10 more would tell us what the 15th term is. Okay, let's take a look at another example here. I'm going to switch up color. We'll go to blue. Okay, we see 6 to 3 to 0 to negative 3. You should recognize these from the beginning of our notes. Okay, I can tell that the difference is minus 3. It's getting smaller by 3. And then I need again, this should say recursive equation, and that would just be, hey, I'm going to take whatever term I'm being asked about, and I'm going to look at the term before it, and I'm going to subtract 3 from that, okay? Whatever term I need to find, I'm going to look at the term before it, and I'm going to take 3 from it, and that'll tell me the term I'm looking for, okay? General rule of thumb. Here's one of those ones with an image, right? Obviously, we see some trees here. What do we see? It looks like there's 3, and then there's 5, and then there's 7. What's the difference from 3 to 5? 5 to 7 is a plus 2. So I would say, hey, the recursive, again, equation should be whatever the nth term I'm being asked about should be the term before the nth term, so n minus 1, whatever comes right before, and then plus 2. I'm going to add 2 to the term before to figure out whatever my new term I'm looking for is. Okay, here's a little challenge before we move on to page 3, the last page of the notes. How many trees are in the 25th term of the sequence? Using this recursive equation or recursive formula, I would need to know what the 24th term is, which means I would need to know what the 23rd term is, which would mean I would need to know what the 22nd. You see where I'm going here? I don't want to have to count. This is term 1, term 2, term 3. I don't have to want to go draw pictures 5, 6, 7, 8, 9, all the way up to 25, right? So this next page that we're looking at is going to give us like a shortcut. If I need to find one far, maybe in the distance, or even if it's not that far and I don't want to just have to count and draw pictures, this next page, which is about explicit formulas, is really going to help us. Okay, so an explicit formula is more so find a pattern. You need to find the pattern and the first term. Okay, pattern and first term. So here's what we need. We're going to look at this sequence again, this 7 to 10, 10 to 13, 13 to 16. Okay, we're going to explain the formula. We should still recognize this is a plus 3. We're going to see how this formula helps us out answer a question like that last one on the page before. In an explicit formula, okay, we're going to see some very similar things. A to the nth is just, again, still it's the nth term. Okay, a sub 1, we need to know what the first term is. And then d again is the difference. So the only new thing we're looking at on this, is we're looking here at this first term, okay, which it's given to us. We see it. The first term is 7, okay? And then we're going to go ahead and make, kind of fill out this table again here, and then we're going to see if we can make a recursive formula. So what do I need? So in this formula, I just need to know, okay, well, my second term is just going to be whatever my first term is. My first term is 7, right, plus 3. And then I need to know what this, I'm going to use this n minus 1. So this is the second term, minus 1, right? And then I have a little bit of math to do here. Well, 2 minus 1 right here is 1. 1 times 3 is 3, and 3 plus 7 is 10, right? Which should tell us the second term, and it is. Okay, I'm going to use that again here. Here I'm going to take, again, the first term. That first term stays. It's still 7 is the first term. We're still adding 3 to it, and this time we're trying to find the third, right? So now I do 3 minus 1. I plug 3 in for this n. 3 minus 1 is 2. 2 times 3 is 6, and 6 plus 7 is 13, right? Here's another one. So still, my first term plus my difference. Here I'm looking for the fourth term, so I'm going to plug in a 4 here. Minus 1 to the equation. 4 minus 1 is 3. 3 times 3 is 9. 9 plus 7 is 16. Okay, so what's our equation? Our equation is just this that we've been using. In order to find the nth term, right, a to the nth equals, okay, we're going to say 7, our start, plus 3, our difference, and then whatever term we're looking for, we're going to multiply it by the term before it, right? Because that 7 just kind of hangs out as that constant there. This is similar to when you've seen something like y equals mx plus b, right? You get your constant, you get your change, your multiplication, right? These are very, very similar. This is just in more of a function notation in subscript with this explicit formula. Okay, so we kind of answered this one just below. It says, what should the formula be for this problem? It would be, what's your start? What is your first term? Okay, our first term was 7. What's our difference? Our difference was an addition of 3. And then we're going to use it for the term minus 1, because that minus 1 takes out the fact that we already have the start in here, our start of 7. Okay, so let's try these. Write an explicit formula for this. You're going to recognize these again. This is our plus 10 pattern. So our equation would be, well, what's our start, right? We need this, we're using this guy, right? So we need, what's our first term? Our first term, look at this, is 5 plus, what's our difference? 10. And then we're going to multiply that by whatever term we're looking for minus 1, so that we can factor in that 5 that we started with. Okay, here's this next one again. We noticed that this was this minus 3 pattern. What's our starting point? 6. Okay, so we're going to say, what do we start with? We start with 6. What are we doing to it? We're minusing 3. And then we need to make sure that we multiply that by whatever term we're looking for minus 1. Okay, let's use one that we haven't seen. You'll recognize this. Let's see what kind of sequence this is. I see that there's 1, 2, 3, 4, 5, 6. This has 7. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Do we see a pattern? I see plus 3 and plus 3. Okay, so let's make a formula for this equation. What do we start with? We start with 7. What are we doing to it? We're adding 3, and I'm going to multiply that by n minus 1. So now this is picture 1, picture 2, picture 3. Look at what we're being asked here. How many blocks are in the 77th term? Do you want to draw picture number 4, 5, 6, all the way to 77? That's right, I figured you wouldn't. Okay, so what do we want to do? We want to take this formula, 7 plus 3, n minus 1, and it's asking about the 77th term. So 77 needs to go in right here. I'm going to write the same formula, 7 plus 3, and I'm looking for the 77th term minus 1. PEMDAS tells us do 77 minus 1 first. So I'm going to see 7 plus 3 times 76. Okay, I'm going to go ahead and do 76 times 3, and that's going to get me 228. 7 plus 228 is 235. That would mean, using this formula, I could tell you that there's 235 blocks in the 77th term, or in the 77th picture. Much quicker than sitting there and drawing out pictures. I mean, nobody would do that. If that was a question, I'm guessing, even myself, knowing me and knowing lots of you just take a guess and move on, right? Nobody, especially on a timed test or something like that, where you just need to do it. You know, your time is valuable. Okay, so hopefully that gave you an insight of these two types of formulas. Explicit is one that's really, really helpful, especially when you're looking at terms far down from the ones that you see. Recursive is one that's kind of just like a, hey, next, now. I know what's now, so what comes next? Kind of just like accounting. And we see some things that are and are not arithmetic sequences. I appreciate you doing today's lesson with me. This is actually the last lesson of the function unit. So we're going to be looking at a test review and a test coming up here within the next week. Ask your teacher any questions you have, and we will talk soon. Adios.